Okay, and this is Don Kellogg, and this is tape 2. Mr. Kellogg, you mentioned to me while we were switching tapes out, you were talking about data loggers, and do you want to tell me a little bit more about, first of all, what is a data logger and what does it do?
It's a means of taking information from the cell via transducers or thermocouples or however we have to take it and recording it automatically so that particular information can be fed directly into a processing machine. Our first data logger, which was one of the first ones in the plant, punched tape, and these tapes were taken and interpreted by the computers.
Okay, and what was it you were telling me about the data logger?
Well, you asked at one time whether we had difficulties with the union. It wasn't really difficulties with the union, but the data logger was deteriorating, and temperature had a strong effect on it. We had fans hooked into the cabinets to cool it as much as possible, but its cooling source was the control room. So I would lower the temperature in the control room below 70 and go home at night. When I come back the next morning, the temperature was raised again. So finally I had a lockbox put on the thermostat, and I lowered the temperature and locked the lockbox. Came back the next morning, and the lock was laying on the table, the lockbox was open, and the temperature was raised back up to 70 degrees. It so happens that I had a shop steward working in the facility at that time, and I'm sure he was the one that did it. But we got along fine, and I understood their problems, so we just made out the best we could until we eventually got some new IBM computers in.
What was it like working with the equipment and technology that they had back then versus, IBM computers? You've seen this evolution of technology.
Oh, my goodness.
Tell me a little bit about it.
When I first came to the plant, we took data manually, gave it to some girls who had accounting machines, and we had quite a genius supervisor for those accounting machines because he managed to take that data, process it through square roots, through logs, and come out with an answer for us. And it was all manual. Girls were using mechanical adding machines. Then we got an IBM 650, I believe it was, in, and we began feeding data still manually, and then they would process it in this machine. Eventually, the computer facilities expanded, and we began taking data on tapes, and then following that, everything was electronically recorded on disks and taken over to the facility for interpretation.
What was an IBM 650? What did it look like?
It was a simple computer, but it could do quite complicated calculations. And it did those things that the girls were doing on accounting machines very rapidly and much more completely and much more accurately.
Did it have a monitor or a punch card?
Oh, it had. The computer was in a computer facility. We have one of the nicest computer facilities in the country, and it was one of the first computers that went into the facility. In fact, I think it was installed in another building first and then moved to that facility.
How big was it?
The facility?
It was IBM 650. Was it?
Oh, it wasn't too large. It was relatively small.
Okay.
Hold 1 second.
So music, or what is that?
That is music. Let's hold the roll. See if. Rolling. Good to go, sir.
Stop. We got church music going on. It's been Okay, and we're back. Let's see, you had mentioned a little bit about the roles of women working at K25, and I wanted to ask you a little bit more about that. What sort of roles did women have working at K25?
When I was first hired in, we had one woman engineer in process engineering. She was quite competent, and she handled jobs you would expect a man to handle. I mean, she went out in the heat, in the hot cells, and did her work. Later, we had women engineers. When I was transferred to the engineering division, we had a few women engineers, but not too many. Some of them were managers of an operating area and later transferred to engineering, where they worked on this improvement program that went on. I would say that they did not hold jobs during my initial phase there equivalent to men, but I think things improved as time went on.
So did they have similar roles, or did they typically serve in different types of positions altogether?
There was many secretaries. All secretaries were women. There were a few women engineers. There was, in my latter jobs, safety analysis, I had several girls working for me there, and they did jobs just as well as the men that were working for me.
Okay, and how were they treated? Were they treated differently, or?
There was one girl that was treated a little differently because she was so independent and didn't take any nonsense from men or anybody else. But she did a good job, and she managed to talk to the people and get their acceptance of her. And she had been a secretary and had been elevated to that position.
Okay. Did you have any contact with African Americans or other minorities that were working at the facility?
Yes. How much detail do you want to go into on that? I mean,
as much detail as you want to give me. I mean, were they treated differently, or what sort of job role did they serve?
We had a secretary who was a girl who graduated from an all-black college. She did typing for us. This was back around late 1970s. But her spelling was atrocious. We had to go through the typed copies and correct them and give them back to her. When I was in the safety analysis department, we had another girl working for us who had lupus, and she came in and she did as much work in 4 hours as the other girls that I had working there did in 8. She was terrific, and she worked on the word processor. It was unfortunate that she was sick most of the time.
Hold on 1 second, sir. If you can watch, flicking your fingernails.
Oh, clicking, huh? Sorry about that.
It's amazing the things that you can pick up audio-wise when you're actually filming, the sounds that you would never even notice or hear anywhere else. Let's see, you said you were married, correct?
Yes.
Okay. What was life like for your spouse and children?
I think they had a normal life, as normal as I had when I grew up. Schools were excellent in Oak Ridge, and they had activities outside of the school which kept them interested. It was like a normal city. I was never here when the gates were locked. You know, it was not a closed city until shortly after I came.
Okay. Did your spouse also work at K-25? Or?
No, she was a homemaker.
Okay. And was she supportive of your work, or did you get to talk to her about work at all?
We never discussed work. I never discussed work with my wife. She just knew that sometimes I might leave in the middle of the night, but she accepted that. And I got up early in the morning. She used to like to sleep late. She's gotten out of that habit now that we go to exercise.
Was there any tensions that happened at the home because she was kind of in the dark about what was going on? Or?
No, none that I know of. None that I recognized.
Okay. So no issues dealing with the issue of secrecy?
No. She understood.
Okay, let's just talk a little bit about living at Oak Ridge, and where did you live and what were your living conditions like?
First time I came to Oak Ridge, I lived in Casper Hall, which was an old dormitory that they had, apparently used by troops before I came there, and it was pretty run down. Later, I was shifted to Cambridge Hall, had a similar room, but the hall was much newer and much more livable. When I got married, we moved to East Village and lived in a house there, and they were fairly nice houses. Not well insulated, but they were pretty nice houses. We had a 3-bedroom, and that's just prior to that, I lived in the garden apartments before we moved there. And then after that, we bought our own house in Claxton. We moved out of Oak Ridge and moved to Claxton. Stayed there for a while, but my wife took the kids to school in Oak Ridge all that time. So it became quite a strain on her, and we decided to build in Oak Ridge. And then we built a home on Netherland Avenue. And we lived there for about 20 years before we went to Savannah. After we came back from Savannah, we built a home in Emory Valley, and we're living there now. Utilities, everything seems just fine in Oak Ridge. We've never had any problems.
And you weren't in Oak Ridge when it was the secret city and it was fenced and everything like that, is it?
I came either immediately before or just after they opened it. The plant area was still blocked. I mean, you had to go through a gate just to get on that reservation. But I believe the city was open at the time.
Okay. What did you do for recreation and entertainment? What did you do when you weren't at work?
Well, initially, of course, I lived in a dorm, and we had lots of card games going on there. Or we'd go out to Central Tavern, which was in the center of town, is burned down, and had a few beers and talked with my friends there. After I got married, I became more serious, and I was civil defense director at the church for a while, and on the PTA, of course, my kids were going there. And then I joined the Elks, was active. I didn't care to go through the offices, but I was active in renovations to the Elks and served on several committees, newspaper committee for one time, entertainment committee for another time. My wife had friends who had come from Cuba, Honduras, and Puerto Rico, and she got associated with them, and so they got together frequently and had a luncheon or something of that nature. And of course, my wife and I went to the movies. We'd go to these plays they had at, I think it was called the Paragon. And I remember one in particular where I brought a dictionary along, and my wife didn't speak English at the time, so I dated with a dictionary, and we went to this play and we hissed the villains and cheered the heroes, you know. So they had a lot of activities of that nature. And then, of course, I was in an entertainment group that Virginia Donahoe headed, and we supplied with the music and had frequent dances, parties of that nature.
Good. Is there anything special or unusual you'd like to discuss regarding living in Oak Ridge?
No, nothing that...
Okay, I'm going to move on to some final questions. So now that I got you all warmed up, these are the big, hard-hitting questions, right? No, not really. Let's see, describe what should future generations remember about K-25? What should be preserved?
I think a typical stage ought to be preserved, a real one, not these mocks that they make that really don't resemble a stage. Some of the data that we generated in the test facilities probably should be put in permanent records someplace. I understand that most of them have been shipped to Atlanta in storage. Some of that information would be useful in the fields of technology and compressor design. We had some tremendous designers in development that did very fine work on the compressors. It would be nice if some of the buildings could be preserved, but of course, as you probably know, K31, K29, and K33 have been completely had all the equipment completely removed from them. some of the stages in K27 or K25 ought to be preserved because they were the initial stages. They were the first design, and it was something that had never been tried before. You know, it was unique.
And you're talking about the stages. Is it okay if I ask what
Sure.
stages are and describe that for me?
Stages? Oh, if they want to preserve a small one, they can preserve one in the 306 section. These stages were, I guess you need a definition of what a stage is.
Yeah, I really, just from a layman.
All right.
I really
All right.
don't know
A stage
exactly
is a pipe which has an A stream going up. This is the stream that has passed through the barrier. A B stream going down. This is the stream that has been rejected by the barrier and passes through a pump. And this process is repeated continuously in different stages, on to the top of the plant and to the bottom of the plant. The enriched stage is accumulated, goes upward, and is a top product off of the plant. The depleted stage goes downward and is taken out near the bottom of the plant. The feed, of course, is always less than we've been taking out in the depleted stages. So the feed was installed at the very bottom of the plant. These stages were the enrichment stages. They consisted of a converter which contained the barrier. The barrier separated the enrichment from the depleted. They had some of our improvements involved eliminating one of the pumps, but generally they had two pumps, an A pump and a B pump. A pump, as the name implies, took the A stream. The B pump took the A stream and the B stream and pumped it to the next stage downstream. They had a control valve which regulated the pressure in the stages. And they had a cooler, generally built into the converter shell.
How many of these stages were there?
Oh, there were thousands of them. Offhand, I don't remember the number, but there were thousands of them. It took thousands to enrich the UF6. One stage did very, very little enrichment.
Okay. Describe, let's see, what great accomplishments were done here and what should be acknowledged for future generations, or what should be acknowledged about the work that was done here?
The original design, the way that a group was assembled with concepts, incorporated these concepts into a design, and built it in record time. And it turned out to be successful. There were improvements made. We decreased power usage quite a bit. We improved the quality of the barrier. We improved the quality of the pumps. But the initial design was excellent. And I think that should be carried on to generations.
Okay, good. If you were telling a story about Elk Ridge and K25, what topics would you cover?
If I were telling the story about K25 and Oak Ridge, I would cover the initial design, the speed in which the plant was built, how effective it was in producing the product that they desired, and how later, when it was expanded, both for bomb production and then eventually for our reactor production, the design and the studies that went into that. Those axial compressors were unique for a gas such as UF6.
What was unique about them?
The flow, the direction they took the flow in, the blade design, and the compression that we got through that compressor.
And I've heard a little bit about these compressors, and I heard that, I guess, the tolerances within these compressors were such that, and then also the weight of the blade, that sometimes when they powered them up, that you could break a blade or whatnot because they were built with such close tolerances. Do you know anything about that, or can you talk a little bit about, I guess, the level of skill and the engineering that went into these things where, we didn't have the same technology to do those sorts of things then that we do today? I mean, was it hard to build these things that had such close tolerance levels?
The initial tolerances on the compressor were close, but to gain efficiency in one of these compressors, you had to eliminate the backflow from the blades. And that was done by decreasing the tolerances. So throughout the expansion program, these tolerances were decreased, and machine shop techniques became more and more aggressive. There were times when the compressor may not fit together properly and a deblade occurred, but generally they did a very fine job in machining these stators. The stators were aluminum. Most of the rotors, that is the rotating section, was aluminum or steel. And the blades, of course, were cast of a special alloy that was resistant to UF6 corrosion. Cast blades trimmed and brought to those close tolerances was really amazing.
Okay, and I've heard that sometimes when putting one of these compressors together, there was a pretty reasonable chance that it wasn't going to, start up because of the weight of the blades. Sort of had a bend on the shaft, or was that, you heard anything about that? And
yeah,
if you got it running, then you were cool, but if it didn't...
When I first came here, they were having a problem in K29. The rotor was a part of the shaft, and it would reach a critical frequency. And when these critical frequencies were reached, the entire floor of the plant would vibrate. It vibrated to a point where it was cracking. And they made studies on this critical frequency and how they might modify the compressors so that this wouldn't occur. And eventually they changed out most of the compressors in K29. In K31 and K33, they recognized that problem and they avoided it.
Okay. Is there anything else you want to discuss, say, or expand upon it before we end this interview?
Yeah, I think nickel plating is something that should be covered.
Okay, talk a little bit about that then.
Yeah, they did a fine job of nickel plating. Initially, our piping was Monel, so that we wouldn't have a problem with worrying about plating. Some converters were copper clad, some were nickel clad, and then they developed a technique for nickel plating. The initial plating was done electrically. The final plating was done chemically. And they had some excellent coatings, only 5 mil thick, that would protect the equipment from UF6. UF6 is a very corrosive gas. And if it's exposed to steel, you have all sorts of problems. During the expansion program, this pipe and all steel was coated with, all steel used in the process system was coated with nickel.
And prior to that, like during the Manhattan Project era,
They used several things there. They used Monel, which was resistant. It has a large percentage of nickel, and it was resistant to UF6 corrosion. They used copper. Copper eventually corrodes and gave them a problem. And they also had a difficulty in cladding the steel with the copper. Plating, they used some nickel plates, but eventually developed a technique for plating that was satisfactory. Now, the initial converters that went in were not plated. It was later on in the program that they developed these techniques. So much of the process piping and centrifugal pumps in K25 and K27, the casings of the pumps were plated, but the impeller was generally made of Monel.
Okay, and with the nickel plating techniques that were developed here, was that, was the techniques or the nickel plating, was it applied to other areas of industry, or was it sort of...
I think the best person for you to talk to about that is Joe Dykstra, since he was responsible for a lot of that plating.
Okay, well, that is really all the questions that I have for you. Is there any other things that you think I missed in this interview, or other things that you would like to discuss that would contribute to the history of the K25 facility?
No, I can't think of anything else.
I can't either, so I really appreciate you interviewing with us and for making this contribution to the thorough history of K25.
There's only one thing that I like to say.
Sure.
I participated in the design in the expansion program. I participated in the testing. I participated in the operation. I participated in the shutdown. And just last year, or year before last, I participated in tearing one of the plants down. So I had it from the beginning to the end. This was in K31, K33.
So, I mean, what's it like to be doing something like this, almost your entire life? I guess it plays a pretty significant role in your life.
I think that in this industry, we're one of the few people that have seen a project go to completion and end. So many people in industry start something and they never see where it goes. But we saw it start, progress, and then end.
Okay.
Okay.
Good. Well, thank you, Mr. Kellogg. Really do appreciate it.
All righty. And don't.
Sir?
What's that?
Just say your alphabet real quick.
Oh, A, B, C, D, E, F. What if you hit one I didn't know?
Let's talk a little bit about K25. And obviously, when people mention K25, they're talking about the U. But the K25 site, I guess, consists of several different support buildings and whatnot. And you wanted to talk about the addition of some of these other buildings and how they were significant. So
Okay.
let's talk a little bit about that.
K25 site contained the K25 and K27 buildings and the K29, K31, and K33 buildings. K29 had been built by the time I got there, and so I merely experienced the problems in 29. One was the shaft going through the critical frequencies, which we had mentioned before. Also, a corrosion that developed on the washers under the blades. These washers would corrode to a point where they would expand the aluminum shaft and break the blade off. What we learned in K29 benefited K31 and K33 tremendously. K29 was one of the first plants that had an axial flow compressor in it. And from their experience on these axial flow compressors, and the experience with these washers, and the experience with critical frequency, they successfully built K31 and K33. K31 and K33 performed amazingly well. They did have some barrier problems at one time, but that was corrected, and the plants have been producing ever since until they shut them down.
Okay, you were saying the addition of those plants was a very significant thing.
Oh yes, the things they learned in K29 and applied to K31 and K33 were the basis of not only K31 and K33, but of Portsmouth plant and particularly the Paducah plant, because the Paducah plant had only size 31 and 33 equipment installed. So it was very significantly different. The centrifugal pumps in the top part of the Portsmouth plant were greatly improved over our pumps. Some of them incorporated 2 stages in one pump, and of course we had a separate compressor for each stage. So they learned much from the plant that was built here at K25.
Okay, great. Was there any other things that we needed to touch upon, or
Let me.
we're